Hello, my name's Bob Willis and welcome to Winnie TV here at SMTconnect. It's a pleasure to have the opportunity of talking to Andreas. Now Andreas, we were talking a little bit about technology, but first would you like to introduce yourself and also what is an area of interest for you at this show?
Oh, thank you, Bob, for having me here. My name is Andreas Karch. I'm the technical manager of Indium Corporation, responsible for the area Germany, Austria and Switzerland. And I have a second role. I'm the technologist for new application in Indium Corporation. And I think to being here, the new technologies in alloys, of course we are Indium and alloy company, what this can bring to the market and to the customer is very exciting for me.
Because low temperature alloys is something that's been around for many, many years, and it's disappointing to some respects that when research was initially done to look for a lead-free alloy, that early failures put people off. But in those days, they were only just doing temperature cycling, and I think that they didn't realize the benefits potentially of low temperature as an alternative to SAC. And obviously you've taken it one stage further with a high reliability alloy.
Bob, you're absolutely right. The time is now here, especially in Europe. We have this energy consumption discussion, we have the sustainability, the CO2 footprint, and that's why people are considering what temperature you really need for your application to get a reliable application. And most of the people, as you said, talking the classic approach, the classic tin bismuth approach, or tactic maybe, but there's some new developments on the bismuth alloys themselves and also completely new systems out there. And we are starting to investigate what can we do for the application with this or with this kind of alloys. And by example, we have the Durafuse LT, which is a complete bismuth-free version, complete different system with a melting point at roughly 190 degrees C, really lower than the SAC 305, saves already a lot of energy. We do measurements with some oven suppliers, how many energy you could save. But this is one part of the story, bring the temperature down, save energy. Another part is, we call this life cycle assessment for sustainability, is you need to produce a reliable electronic device because this is really sustainable if you have the long mission profile. And the new system, the Durafuse LT, can do the job. It's really close on the SAC 305 performance and reliability.
Were the customers that perhaps were put off with the word bismuth originally, because obviously a lot of your customers are in the high reliability market, so was bismuth a word not to be mentioned, and that was again perhaps another motivating factor to look at a more reliable alloy without that word in it, because it's emotive?
Yeah, absolutely. We have a lot of automotive customer, and they have mission profiles, they have temperature cycles and a long time. That is the most important thing, is the long-term reliability over the mission profile. But as you mentioned, the bismuth is also developing further. There are bismuth alloys out. They may be now fit for some application in this field. Maybe not in the hottest application, but for some application. And that's why I think this is good for us and also for the user of this older material to think about the use case and see what the new alloys can do for you. That helps you a lot to bring the CO2 footprint down and at the same time add reliability to your system.
And as well as availability of materials, obviously solder paste, but cord wire?
For the new system, we're working on this. We have today in the PCIM, the partner show here, is we put a presentation on preform. This is also a solid piece of solder. This is not a wire, but we have made it to bring the Durafuse idea in a preform, and you can use it in the power electronic as well. And we're working also on steps in wires. But we have some bismuth, advanced bismuth alloys also on wires. We call this bismuth plus. There is something changing of the brittleness. We want to get rid of the brittleness as much as we can from this material, as you know. And this is a challenge in the wire production. You can imagine.
But do you think that there is a need for it? Because a lot of people have said to me that we will just use another lead-free alloy for rework and repair, although we're using the high reliability alloy for the main production reflow technology. They're just happy. Because I've always tried when I'm working in manufacture to define a process where you're using all the same materials, because there's less opportunity for error. But perhaps there is a way of using an alternative alloy for touch-up and rework without the need to develop a new product specifically for that.
I think the point is maybe not touch-up and rework, but for the complexity of the electronic devices today, people need a hierarchy of alloys. System and package is one of them. This gets in the cars as well. You get all this graphic functions, this ADAS, radar systems and all, and then it's good to have a hierarchy of reliable alloys. Have a lower temperature, and then you take care you don't remelt all the motherboard if you put maybe a graphic computing system and package on top. And this way starting people more and more looking in different kinds of alloy systems. The main, the people like to have one for all, but I think the time is a little bit going to have one for all.
Yeah. Again, it's, as a process engineer and as you used to be a process engineer, I mean, you're still a process engineer.
Yeah.
But I think the development of a process, finding the right combination of materials, but also finding the right tests. Sometimes we test a product to a specification, and perhaps there should be another test method which is better and more appropriate for the application.
Absolutely. Your experience, you know this, yeah. You need to look in your mission profile, yeah. And everybody want to accelerate the lifetime tests, but you can over-accelerate. If you have a low temperature alloy, you cannot do the same test like with a high real alloy. Of course, you need to find out what is the acceleration factor. There are models out, but you need to a specific test for specific alloys as well.
Yeah, I mean, it's okay to have models and it's okay to have a specification, but in the real world, what we would like to be able to do is define a process, define the reliability we want, have the test method, but actually do some sort of physical testing at a slightly accelerated factor to prove that we do get the same failures in the same place, because we've gone in the wrong direction sometimes in the past. Absolutely.
If you use a different alloy, you get maybe a different failure mode. Yeah, is it cracked the bulk solder or is it cracked in the interface? Yeah, if it's stiffer or is it more ductile? This is exactly what you need to learn on the failure mode. Yeah, and of course the system itself, what you produce, yeah, your ECU or whatever you produce, needs to survive the whole mission profile. But the simple test for all units needs to adapt it on what you do. Absolutely.
I mean, obviously a question to ask is, what is the difference in price of materials? That's obviously a factor that people need to consider. Obviously, an alloy which has a greater range, a greater reliability, is going to be slightly more expensive than the cheaper end and the business materials. But can you give us some sort of indication? Is it the same as SAC? Is it?
To be honest, I'm not the guy for the money. This is salespeople. But if I know the elements they're in, this means the dual fuse LT must a little bit higher than the SAC 305 because there are more other elements in. That's a more complicated process. But this is not like a gold tin or like a jump, like massive. No. Yeah. No. But the final prices, you need to talk to the sales guy, to be honest. I have no idea.
Okay, well, thank you very much, Andreas. It's great to be able to talk to you, and it's nice to know that us process engineers do stick together occasionally.
Absolutely. Easy.
Thank you very much.
Thank you very much.
My pleasure.
Bye.